Alright, let's begin our first day of class. Right, let's go over this first. What technologies will this course cover? And how will it address our future work needs? First, we'll cover enterprise network architecture basics. For instance, what's our main goal in learning about this field? Just preface, we're here to meet our enterprise's various needs. Many of you are looking for work, right? Those new to the industry, pay close attention. Anyone learning a new technology, right? Why learn any tech skills? It's because new demands keep popping up, so businesses have many different needs. Our network needs will also keep changing. From your dorm room, your home needs, right? Enough for a network, right? To larger scale ones like public networks, government networks, even service provider networks, small to medium ones, right? Like your average small and medium businesses. There's so much to cover. So when it comes to our networks, they come in various sizes and types. I'll share a few examples later on. So remember, learning about networking is all about meeting our ever-growing needs. Alright, now let's dive into our network universe. Just like we saw with Huawei's direction earlier, it's similar to our own Milky Way galaxy. Aside from our two main focuses, routing and switching, they form the very foundation of all our network communications. Always remember the purpose of routing and switching. It's to understand how networks connect. How to establish network connectivity. Once a network is connected, our internet access fundamentally relies on routing and switching. That's essentially all there is to it. These two major technologies alone enable network communication. Everything else is added on later, like security and VPN security, bandwidth management. All that advanced stuff is built on top of this. So keep this in mind, alright? If you don't master these two, there's no point in learning anything else. Just like if you master routing and switching, you'll pick up security in no time. Everything else builds on this foundation. That's why we call this the road. Right, if the road isn't there or it's not built correctly, what's the point of building things like restaurants on it? Some places serve no real purpose. So as the old saying goes, it's like when the railway is built, it brings a fortune. So roads and highways, once they're built, everything else will follow. This saying has a really deep meaning. Like in those TV shows, the vast universe, endless and boundless, truly unfathomable. So regarding our network examples, each example is like a stored record. Each one is unique. You might encounter similar examples in your future work. Right, we often use routing with VPNs. Yeah, I set up VPN connections for the company. Those are the two main aspects. Got it. When some companies set up their intranet, it's mainly for data exchange, right? Take load management, for instance. Data centers can't live without virtualization. They're thrilled. It's crucial for them, right? So you'll be learning a ton. We cover a lot of ground. But in real-world projects, you'll usually focus on just a few key areas. The concepts we learn might only apply to this one case. A lot of students get confused here. They'll say, I've learned all of this stuff. I'm only using these two in my current work. In fact, I might just use one or two. So does that mean the rest is useless? If you think that way, you'll come completely wrong. That's totally wrong. Got it. So please don't think of it that way. So when it comes to learning network technology, it's like observing the stars at night. This is just a piece of the puzzle. That's just the tip of the iceberg. Moving on, let's explore the applications of our technology. Yes, these are some of the key areas. Take the Anhui Guangdong Center across from us, for example. This impressive building is a landmark for Anhui Province. Wouldn't you agree? Across Tianhu Lake, right outside this window, is the municipal government office. Besides government, public security buildings, Hefei is renowned for universities. From primary and secondary schools to universities, not to mention finance and securities. And what about venues? Think of any sports venue. Nowadays, they all have internet access, let alone cloud computing for large enterprises. So it involves all aspects, including small and medium businesses. Even our homes, it's all around us. In this course, we'll mainly focus on all these technologies and fields. The core equipment we'll be dealing with are mainly these three types, switches and routers. This course mainly focuses on routing and switching. Firewalls, they're crucial for network security. Nowadays, many companies use firewalls for their internet connection. It's best to use a firewall if you can. Firewalls can completely replace your routers, and they offer better security. Firewalls, basically, it's not that our teacher just said firewalls are great. Every company uses firewalls at their network exits, but keep in mind, prices vary for a lot of things, so do the functions, and your company's budget matters. Our teacher said firewalls are great. You won't even need routers, just one firewall. Turns out a firewall costs 200 to 300 grand. Our company is tiny, and router will do. A router is more than enough. We don't really have security needs. No need for that. We can't get a firewall. So here's the thing. Especially for you college students, companies have to consider the costs. It's not about just using the best stuff. It's like when we buy a car. Are Ferraris and Porsches any good? Sure, they're great. I can't afford them. I just need something to get around. So a Volkswagen or something similar would do. A few tens of thousands would be enough. Right. Heck, even just right and big. Right. You see, it's the same as with our work. It all comes down to what you need. Money is no object for the wealthy. It's about using the best of the best. Alright then, let's talk about routers and switches. They come in many models. Let me give you a simple example. When you run into problems at work in the future, there are many commands I didn't cover in class. There's just too much I haven't covered. Make sure you check the product's official website. Take a Huawei for example. Specifically the Huawei devices I've worked with. Say there's a setting. What if I don't know how to set it up? Go to Huawei's official website and find technical support. You see, Huawei has a wide range of products. Just look over here, right at these products. Let's take switches as an example. You'll see just how many switch models Huawei has. Right, look at Huawei switches, and then their routers. And look at their servers, they have tons of those too. So for a manufacturer like this, they produce a vast range of product lines. We can cover all of this in just a few days. No, we're focusing on the core universal elements. So these products are also aimed at small businesses. Those on a budget should use the most basic models. What's suitable for SMEs and what's used by high-end carriers. They're all different. Do you think they are the same? The prices are different. The functions are different. The performance varies. There are many differences. For example, if we take a switch. Just take the switch for example. Models for IE exam and main course exam are Series 3 and Series 5. The one on my desk is Series 5. Our company mainly uses Series 3. If you just look at Series 3 or Series 5, you'll find that Series 5 alone has many models. What does all this even mean? What do these suffixes and letters actually mean? Get it? We won't go into product specifics, because it's quite simple to understand the manufacturer's products. Now that you're in this field, just check the product manual or look at the product model codes. You'll get it quickly. There's no need to cover it in our course. Our exams won't test on these product details. That's the case mostly. So you need to understand what functions these have and what kind of testing is involved. For example, let's take the basics, right? Let's check out switches on JDCom. See, some of our switches are as cheap as 10 or 20 yuan. I sometimes bring one along when I'm out, like this one here. This one's 24, 9. Right, the pretty ones are a few hundred. Say we pick from Huawei, H3C, or Cisco, like Huawei's, like the ones on our table, which go for hundreds or even thousands. Check out this expensive one. Let's go with this one for 3,500. So it's just models 3, 5, and 7. So why does this one cost 3,500 yuan? This one has 48 ports, but mine only has 5. Mine is only 24 yuan. Even if I buy 100 of these, it'll only cost 2,400 yuan. That would give me 500 ports. Yours only has 48 ports. Why is yours 3,500 yuan? Look, this 5-port one is only 24 yuan. Look at the product description in this ad. Does it say anything? That's all it says. It's just about basic networking. I bet many of you here might not even know what a switch is, or how a switch works, or even why we need one. That's what we'll cover in this course. So looking at its specs, that's all there is to it. Take a look at this 3,500 yuan switch. You need to learn to understand this. First, these specs. In my company, you bought this switch and put it in this position. Is it enough to handle our company's network traffic? Do you think the forwarding performance can match a 24 yuan switch? Right, and then there's this. This is what we're going to learn. RSTP and MSTP. This is a common IE interview question. Explain the differences between these 3 types of SDP. And what's SmartLink? That's unique to Huawei. We'll cover this only in the HCIE course now. It used to be part of HCIP, but not anymore. Now it's covered in the HCIE section. This is actually an optimization feature of Smart SDP, so you need to understand these parameters. Let's check out the various security controls below. What is a method authentication? What is 802.x authentication? What is port authentication? What is an anti-DDoS attack system? What is a VF interface? What does dynamically applying user policies mean? Do you get what that means? And what about stacking technology? That's it. And what's traffic analysis technology? Like SLO, P, NEFA. So what's management technology? V2, V3, you'll learn about all of these later. You'll see it in all kinds of products across many industries. It's not just networks, secure storage, basis, operating system. You'll find this data across all kinds of professional systems. Get it? That's what you get with professional products. I think you'll find this in some cheap device. No way, cheap gear doesn't have any of that. This stuff, enterprise networks are already used across all industries, from small businesses to medium-sized enterprises, and even large corporations, government and educational institutions are using it too. We'll go over some solutions later. Let's talk about remote access. This is where VPNs, a key technology we'll discuss, come in. This diagram illustrates VPN technology. Almost every company you encounter these days, even small businesses, will provide VPN access to their remote employees. Large enterprises often use IPsec VPN for direct interconnections. So, we're talking about remote network interconnections here. This isn't about surfing the internet. Many students ask, is this the same as using the internet? In this diagram, this could be Beijing, this could be Shanghai, Hefei, someone on a business trip in the US, and someone working from home. So what are we talking about here? Our headquarters has a lot of resources, like server resources. Our service resources, we want to access them. But as you'll learn, our networks are all private. Corporate networks are private too. Even your home network is private. I can tell you, your mobile 4G connection is also private. When you're on 4G, your IP address is a private one. I'm telling you, so you'll learn that we have a private network here. Use it, you can't access it from the outside. It's completely sealed off. Those on the outside can't see any details within. Just like our company's network. Take out our company's network, for example. I've configured it. I've set it all up. It has multiple wireless access points. It has multiple VANs. It has multiple network segments. So our company's network, for instance, if we were to contact our company's network, we have 5 VANs, entry form, orange base IPs. I've set all these up. That's how you can connect here. For instance, our students, you're on the STU network, I'm on my own Wi-Fi. All the staff are on the office network. Each wireless node is in a different location. That's why the signals vary. We don't want our wireless signals to clash. And we don't want network segment conflicts. That's why we have different network plans. Think about it. Our network structure, our network plan, right? Do outsiders know about our network architecture? Outsiders don't know about it. Got it. So outsiders can access our network. But a lot of students are probably thinking, then how come we can get online, Professor? It's like I said, by using an AT device. In other words, I have to reach out first, then people from outside can reach me. It's impossible for them to initiate contact with me. Got it. So basically, every network card has an address. Like I said, every network card has an address. My address right now is 192, 168, 108, 228. I can ask anyone to find this address, except, of course, for those taking classes here today. Anyone can look up this address. No one in the world can access this address, except for those in our company. Nobody can access my address. Direct access is impossible, unless they use a specific dial-up method. So this is what we're talking about. Our server might be on the company's intranet, or other locations around the globe, any office staff with internet access, really. How do they access this server? This is where remote network connection comes in. This is our key technology. And our technology, when we get to MP, I'll show you just how amazing this technology is. Right now, I'm located, simply put, in Hefei. Our company uses Hefei Telecom's broadband. This is the IP address we're using right now. Everyone here uses this IP to get online. We just have this one IP address. We only have one broadband account. We only have one public IP address. This is called NET, but your network addresses are different. You're on the 200 subnet. They're all assigned by our core switch. Once you connect it today, we'll use this for allocation later. So don't worry if you don't get it yet. Go ahead and change it. Let me give you a quick demo. We'll get into the details later. You're all listed here. This is the address you've connected to today. These short connections are all yours. These longer ones have been connected for a while. See, this one's almost a full day. 86,400 seconds is 1 day. Right, 86,400 seconds is a full day. Ours, the least time is just 1 day. So this will automatically release after 1 day. And these connections are all from you and the colleagues next door. Do some of the students next door get it? See, they were almost all connected just today. Right, so today honestly, how many devices are connected to our company network right now? Let's check this out. 70. Usually from Monday to Friday, it's around 20 or 30. Today we're at 71. So don't worry if you don't get it yet. Let me show you how it works. You'll get the hang of it soon. With this information, I can find out how many people are connected to our company network today. I can even pinpoint your location. These are all things you'll need to figure out in the end. So as a professional engineer, you'll see he's very professional. He's just typing away at the commands. He gets whatever he wants with those commands. You and I were the same. We learn as we go. Alright, let me show you something cool. So today I'm on the HCIA Datacom network using VPN technology. I can instantly connect anywhere in the world. I happen to have access to Tencent's internal network. Let me just connect to it. It's a breeze, done in seconds. Alright, check this out. Guess where I am now? I'm not in Hefei anymore. See where I'm located. I'm in Haidian District, Beijing, and I'm using China Unicom. Get it? This is Tencent's internal VPN. How do you get this? Right, of course, you need the right connections. You need special access. Let me tell you something. I'm on Tencent's intranet right now. This isn't something I just made up. I'm telling you, seriously, I'm on Tencent's internet. This is really Tencent. I used to write about stuff like the internet, you know, the Givers Alliance or whatever. This is what I just got a couple of days ago. Tencent internet. Did you notice? My location instantly switched to Haidian District, Beijing. Beidou won't lie, right. If you look it up on Beidou with this IP, the information Beidou gives you is usually reliable. It's usually accurate. The address changed. The location changed too. I'm telling you, this is real. Haidian District. So now, wherever I go online, it'll show that I'm in Haidian District, Beijing. So that's a VPN. You'll see what I mean later on. Disconnected. Let's do that again. And I'm back. Pretty cool, right? That's the power of the internet. So what I'm saying is, really mastering networks. I mean, really knowing them and all their applications. Not many, actually. Let me tell you. Nowadays, many people are studying every field. Take database development, for example, many are learning it. If there's one thing China doesn't lack, it's people in this field. But what we need is top talent, real experts in the field. Get what I'm saying? It's simple. You're all learning from the same teacher, resources, working on the same stuff for ages. That's where you'll start to differ. It comes down to your aptitude and how hard you work. Simple, right? I'll show you. I just gave you a demo. We'll get into the details later. This is VPN technology. Suddenly, I'm in Hefei. It's like I instantly relocated to Beijing. I'm right inside Tencent's network in Beijing now. That's how it works. This is VPN technology. This is a major topic. Move in. Let's take a look at the architecture. Let's start with this diagram. As we progress, the course will delve deeper. You'll gain a much deeper understanding of this diagram. Let's compare small businesses with SMBs and even large enterprises. First, let's look at small businesses. Let's take a very simple example, something we all have at home or in our dorms. This right here, we have several at our company. Nowadays, many restaurants use these as well. So, I've noticed we're using the internet now, buying broadband routers. Why can't you get online with this router for just 99 yuan? It's so easy. I just sign up for broadband. And then, we all know this, right? Anyone who set this up knows. These broadband routers have a feature. Look at this diagram. It has a feature. It has a WAN port and a few LAN ports. Right. These types of routers all have this feature. So WAN stands for Wide Area Network. What does that mean? Basically, connecting to the external network means connecting to your service provider's network. When we go online, we're accessing this wide area network. It's the global network. At home or any of these, we're actually on a local network. To access the wider internet, we have to go through a service provider. This is a national regulation. It's regulated by the government. No company or individual can access the WAN privately. Basically, it's the internet. We have to go through the operator. So the operator provides you with this broadband line. Right. If you plug it into the WAN port backwards, you'll find it doesn't work. And then I found this to be very simple. I'm not an expert in this field. I can follow the instructions. Just a couple of simple steps. Many are set up using QR codes on mobile apps. I just need to set up my broadband account. Then I can get online. Don't know anything else about what's inside. You don't need to know any of that. It's all good. So here's the thing. This is how it is for small and medium-sized businesses. Just small businesses. It's the same with many restaurants. It's just a broadband router, you know. Or for example, let's take a simple case. You know Faizhu Goji, right? It's quite popular in Hebei. So if you go to a small restaurant like that, so he's got Wi-Fi. He just bought a broadband router and that's it. What about small business networks? So, is there anything technically advanced about this? Not really. Then why can't I get online with just one device? From a professional standpoint, this broadband router combines those three devices. It's a simple combination, and it's all pre-configured for you. HCIA approved. Let me tell you something This right here is the WAN port. Otherwise, it wouldn't be called a WAN port if it connected to the cloud. This is where the WAN connection plugs in, so that you'll see anywhere from 1 to 4 LAN ports. These are your LAN ports. Got it. These are the LAN ports. This is what our first broadband routers looked like. The broadband routers back in my day looked just like this. We didn't have Wi-Fi back then. It wasn't as widespread back then. So what did we use broadband routers for back then? To let everyone in the house share the internet. That's why. Why did we need a broadband router? Yeah, everyone knows about broadband routers. Alright, let's set up the network. Yeah, it's very simple. Take a look at these pictures. It's all explained clearly in the diagrams. Right, setting it up like this. The broadband comes in and plugs in here. So the LAN port connects to your home's multimedia box. Right, and then to other rooms like the bedroom or living room, IPTV. You see, before this, back in my day, when I used broadband, the broadband connected directly to my desktop computer. My desktop dialed up to get online. You didn't need a broadband router. So this is where people get confused. Do you really need a router to get online? Who told you that? Is that? See, it's because you haven't really looked into it. You're stuck in your ways. You see, you think we had routers back in the day. We didn't have those back then. We just plugged the cable into our PCs and dialed up. So a lot of the time, suspecting a router issue is simple. Just plug the internet cable directly into your computer. Dial up on your computer. Computers can dial up to, it's the easiest way to test your router. So you get it. What do we even use routers for? It's for sharing, of course. Sharing is their main purpose. It's not just one computer needing internet access at home anymore. I have multiple computers at home. So what do we do? Oh, now everything at home is wireless. Laptops, tablets, So we need to add a wireless AP. What's this wireless AP for? It sends out the wireless signal. So these three professional devices combined make up our broadband router. This is like its antenna. Or you get it now. So this is a small business network. So within this setup, besides knowing these three devices are combined, you also need to understand that on this side, we have METI technology. No configuration is needed. And over here, we've already configured the default route. The outgoing interface is the WAN port. You don't need to configure this either. It's all set up. What's enabled on the internal network port? So when you plug in the network cable, you'll get an IP address when you connect to Wi-Fi. But many students in this class don't understand IP addresses, right? That's why you're in the dark. It's all pre-configured for you, not all set. Routing is all set. TCP set up too. You don't have to worry about a thing. Just set up your internet account, plug in the network cable, connect to Wi-Fi, and you're online. But there's so much you don't know. So as we know, for these medium to large networks, why does he need such specialized gear? They all use that stuff. It's cheap, can it handle it? It can't handle it. ISPs have that kind of gear, right? No way. Right, not a chat. Think about it. This thing's only for 150 megabits per second. The best selling ones now, top-notch high-speed routers, over 1000 yuan. Even 2000 yuan high-speed routers are available now. Those with dual shell, dual screen and 4 gigabit. A Lahomie is a high-speed router. Can actually sell for 2000 yuan. Don't worry about whether it's right or just a gimmick. Let me show you the equipment used by carriers. See, you can see the equipment used by carriers. Let me pull up a resume of one of my former students. This one's a no-brainer, graduated in 2015. When he was a junior or senior in college, we recommended him for an internship at China Mobile. He got an early start. He's now even gone beyond the HCE certification. He was very bright. Back in 2012, he was already passionate about this field. So he started studying with me back in 2012. In 2014, he joined the China Mobile Internet Center in August. Here he worked as a network engineer and operations engineer. He already had his Huawei certification then, and here his responsibilities included configuring public network access for clients, implementing routing policy deployments. The main equipment we use is mostly Huawei. These routers are the high-end backbone routers I mentioned earlier. We also have HVC's 93 series switches, the 12,000 model. We even have some Cisco equipment, but mostly Huawei, and servers, of course, Inspur and Dell ones. Now look at the projects here. These involve clients like NetEase in Nanhui, for example, for their router deployment, and then Tencent. Tencent's uplink was 20 gigabytes, 360, and Taobao 40 gigabytes. This was back in 2015. And then IKEA, their video streaming platform. They need way more bandwidth, 160 gigabytes. Do you think operators would use this equipment for such projects? Right, so, professional equipment is totally different from what we use at home. Even when issues came up, like Youku's traffic getting stuck, similar issues happened. What kind of issues? How were they fixed? Troubleshooting. He's got this kind of experience now. This resume was last updated in 2015. He's got his CE certification now, and all this experience, right? So he's really improving. It's that simple. See if you can gain this kind of experience. You need to build it up. Now, let's answer this question. This is a typical example of what we've learned in this course. A medium to large enterprise network architecture, access layer, aggregation layer, core layer, server cluster. This includes our end users, desktops, wireless devices, right, and even printers. They're all included. Got it. Take our company for example. When you come here for exams, we will have cameras monitoring you. The cameras are connected to our algorithm via the network. We can monitor the exam in real time. We can monitor the exam proctoring in real time. Students are taking exams today and tomorrow. Look, Jiaotong has students taking exams today as we speak. This is how you do it from now on. You will be taking the exam here. And both the and IE exams are taken this way. All written exams are taken this way. But the IE lab exam is taken elsewhere. It's a full day exam. The interview is also taken at Huawei. So this is the exam. This is our company's surveillance system. Many retail businesses use surveillance now. Hotels are full of surveillance cameras. Surveillance is everywhere. Ever thought about that? I can access this on my computer. By typing in an address, I can view our company's surveillance. It's essential. It also records and takes photos. Now, let's compare the left and right sides. You'll notice something interesting here. First, take a look at the right side of the diagram. Why are there two of these devices? There's only one on the left. We've got two of them here. Looking at the diagram, that's the first thing you see. Why is two devices? Ever wondered why? Okay, let's summarize. Enterprise network architecture largely depends on a company's needs and its business requirements. Take small businesses, for example. Like a small home-based business, a small shop. Would they need to spend thousands on specialized equipment like this? Probably not. A simple broadband connection will do. They just need a flat network structure. No hierarchy, completely flat. What are the benefits? Low cost and flexible. Maintenance and deployment costs are minimal. Plus, it's very flexible. You can set it up or not, it's up to you. Just grab the equipment and go. It's super simple. No need for major overhauls. The drawbacks are obvious. For engineers like us, the drawback you're talking about, it lacks redundancy. A line's down. A port's busted. The equipment's down. You're paralyzed today. It might not be a big deal at home, right? For our company, for any business, everything might just grind to a halt today. Quick, Xiaowang, go get new equipment, right? We've been stuck here all this time. So this is the downside of this approach. It lacks a redundancy mechanism. The reliability is poor. It's prone to operational issues. This is currently the top concern for most major companies, reliability. Since device performance is already quite fast, basically reliability is what limits you. When a company's business is booming, can it consistently deliver? You might recall several major events a couple of years back, like when celebrity Wang Baoqiang announced his divorce. Remember, it was announced in the wee hours. Weibo crashed again. Weibo's servers were overwhelmed, as was its network. They hadn't anticipated such a massive spike, had they, in service demand, or whether it was network bandwidth, not to mention our servers' processing power, and all the other applications running in the background. Exactly. It can't handle hundreds of thousands of concurrent users, let alone millions, right? It will crash immediately. It was even worse during the Spring Festival train ticket rush. You couldn't get a ticket. Same thing every year during Double 11. Everything crashes at midnight. It's the same principle, it's inevitable. So that's what we mean by reliability. The examples we've given are just typical. You might have encountered more of these. Right, but a network outage at places like banks or government agencies is a big deal. I have a student who works on network operations at a government agency. Let me tell you. But one day, by accident, he accidentally restarted the device. He meant to restart the DHCP server. Instead, he accidentally restarted the core switch. This caused a 5-minute network outage. The phones were ringing off the hook. If the senior staff in his department found out, if it's 15 minutes, I might have to quit. So your sense of responsibility grows. It's even more critical for telecom networks. If you accidentally crash the network, right, it could affect areas from Hebei to Shanghai to Nanjing. Their network communications, that you could affect hundreds of thousands, even millions of gamers. Oh no, they're in the middle of a team fight, and it crashed during the competition. Honor of Kings crashed. Tons of complaints hotlines will be flooded. So, as we mentioned, small businesses don't have this feature, nor do they need it, right? So it has clear pros and cons. But a single large enterprise is different. What they aim for is high reliability and business continuity. This is achieved through redundancy and backups. Does that mean always having 2 or 3 devices and connecting 2 of them? But that's not enough. We need to learn how to properly connect these devices. Once connected, we need further configurations, like link aggregation here, ND here, and even stacking technology over here. Get. Otherwise, let's look at this example. Here's one gateway, here's another. The PCs below need a gateway configured. So, should we use the gateway on the left or the right? You can't just choose one. Why? What if you choose the left one? What happens if the left one fails? Switch to the right one. Who's going to do that? Thousands, even hundreds of devices down there. Who changes the gateway address? Nobody. So we need something like a virtual IP or stacking to provide us a single address. But we have 2 or 3 devices working together in the backend. So things like clustering, Virtual IP these ensure reliability and easy backups. It's not just about having more devices and cables, okay? We need to make selections. Large enterprises have specific requirements. For instance, traffic management. Let's take our company as a simple example. We have quite a few people at work and students in class today. We need to prioritize our exam network in case of any issues. Right, some might be taking exams online, and then we have our office network. In large companies, the boss might be in a meeting from home and on a video conference if someone starts using a downloader, right? Many employees might secretly watch HDTV in their spare time or use downloaders, right? Because you can't possibly monitor employee behavior every single moment of the day, especially in large companies. Take us, for example. If I start downloading, many people might experience slow speeds. For example, if I download a movie, let's say a movie. Okay, our company has a 100 megabit broadband, so the download speed can reach 10 megabytes per second. So if I start downloading, other employees might notice, oh, why is our internet so slow? It suddenly froze, I can't send anything. Uploads are slow, there's a lag and images aren't coming through, right? See, I'm already maxing out the speed, almost at the peak, yeah, 10 megs. Yeah, it's about to hit 10 megs. So, say an employee or the boss comes up and says, why is the internet so slow? Especially at home in the evenings. You're gaming and your whole family is streaming HD videos, you'll notice the lag when you're in a team fight. So, in this situation for our companies, it's pretty straightforward for me. Alright, just locate the company's network exit. Right, log into our company's network exit. Let me check, are there any traffic spikes on the bar graph? It's simple. This is the download traffic, see? This is the normal average, around a few megs, 3, 4, maybe a bit over 1. We've just noticed our traffic spike to nearly 8 or 9 maps. Something's wrong. So what's causing this? Easy, we've got a list of all IP addresses ranked here, sorted by download traffic. This IP is the culprit. MPs normally uses a few hundred KPs or a couple MPs. We found the issue. Let's take a closer look. Check the details here. It's all Shenglei downloads. Just scroll down, see? All Shenglei. Yeah, nice, right? So what's next? Easy, we'll throttle it. Think you're fast. Let's cap your speed. Boom, take a look. See, clear as day. You can try all you want, but I'm in control of the bandwidth. Right, it doesn't matter how fast you download. This is a bandwidth management in a nutshell. And that's exactly what engineers in our field can do. A lot of people finish their studies and have no idea what to do, just like in college. Okay, so you're wondering, what can I do with this? Let me show you. I can do a ton of things. Simple, direct, and super practical, right? See, and that's just one piece of the puzzle. I think I cut the connection, didn't I? I noticed something's up. Someone's downloading stuff. I could block the downloads completely. This SQ network you're on. Here's the thing, if you try to open Youku, it won't load. Same goes for games. Why? It's simple. I'm managing the activity on this SQ network. See, these apps are blocked during class. No streaming gaming or speed tests. I did this to stop you guys from messing up our work. Right. Some of you might say, teacher, I'm not restricted. Some might say they're just goofing off or playing games, but that's on you. You're just wasting your money. Not my problem. I've done all I can. So, these restrictions aren't about using some special tricks to get you to focus. Whether you listen or not, that's up to you. We're all adults here. Let's be reasonable, okay? I'm doing this to avoid messing up our company's network. Right. See, I can get on Youku now, right? Adding one is so easy. We're blocking all online videos, and who's blocked me? I just blocked myself. Luning, confirm patch, check. That's straightforward. Now watch, I'll open Youku again. See if it still works. You can still access Youku's homepage, but what about the images, the video previews? What about the Chuo sessions? They're gone. Let's see. See, it's that simple. You want to watch something, it gets blocked. Okay, refresh, and they're back. Get it. That's why companies need this kind of employee monitoring software. They can't have someone watching over your shoulder all day, right? Hey Jiaotong, stop that. You're on Taobao again, chatting away and watching videos. Right, you're on 1-1 again, right? One more thing, for those of you still working as engineers but not in this field yet. I don't know if your company's software can monitor your chats, but let me tell you this. Many security products, especially those for export, can monitor chat logs. That includes your QQ records, your new messages. For example, our company exports. Take behavioral records, for instance. As long as you're using our company's equipment to go online, I can see every website and domain address you visit. See your QQ number. Your login and logout methods, I can see it all. See, nothing is hidden. This isn't really private stuff. Just showing you it's all technically possible. Every website you visit, everything you look at, your QQ logins, accounts, platforms, I see it all. I have a record of your online and offline times too. So, can you actually see QQ chat logs? Here, let me show you a screenshot. It's from this company. Let me show you a screenshot. It's called Instant Messaging Chat Monitorer. Alright, now check this out. Here's a log of all employee access records. It knows what you downloaded. Tencent data, email contents all get logged. Your searches are tracked too. I can restrict or allow you access. Let me show you a chat log, for example. Here's an example. See this? See, we're just testing it out. The date and content of the chats are all here, even pictures. Look, there's more down there. Here's the chat content. We're just testing. We just sent a random video message. See, chat's content is all here. Everything's right here, including who sent what to whom. Okay? So, you guys really have a lot to learn about networking. This is how we manage user behavior, browsing, and access control. Our network is designed with multiple layers. Access layer, aggregation layer, core layer. What's the purpose of this? It's for offsite expansion, because many companies sometimes expand the department. Right, they might even build a new building. Right, like building a new facility, a new base, a data center, or a server room. So you need to consider remote expansion in your design. Take a router, for example. It only has 4 ports. What if they're all full? Buy another one. When you're choosing equipment, you need to leave some ports free when planning. You need to set aside space for future expansion. So we need to consider scalability in our design. And then there's maintenance and network management. We might have failures here, either here or there. Unlike at home, where one device might fail and it's down, in an enterprise, failures might be concentrated in one area. You need to know the differences between these areas. Which devices are affected when a failure occurs here? That's what you need to figure out. So, this is how large enterprises are. And now let's look at the network characteristics of large enterprises. The first and most typical one, operators. Here are some keywords. Check these out. Not many of you will end up working for them. The reason is simple. They have the highest technical requirements. And that's no exaggeration. Telecom operators, the requirements are very high. Besides frontline positions, they look at your education, your major, and technical skills, of course. So at these companies, first, its coverage is vast. It covers entire provinces, cities, the whole country, and even the globe. The network is complex, technologically complex. Network security and high availability requirements are extremely stringent. The key is the sheer number of coexisting devices from different vendors. Your company or even SMB might only have devices from a single vendor, but we as telecom operators, in the previous students regime, we deal with various vendors and high-end equipment. Setting up these networks also requires extensive knowledge. For instance, operators don't just deal with the broadband networks we're familiar with, access and transmission networks, VPNs, all kinds of networks. What makes these networks so complex? The protocols, BGP, MPLs, you name it. So, working with carrier networks is a real challenge. Get it? If you get a chance to work as a support engineer there after 6 months or a year, you'll be dealing with cutting-edge tech. It's pretty cool stuff. Got it? And they're all incredibly complex. This will rapidly enhance your skills. This is the operator's network. Second, then there are the government agencies, especially the government. They have a specific feature, our network ID. Take the Hebei network, for example, right? And the surrounding cities near Hebei's network, like Lujian, which is also in Hebei, right? Take Lu, for instance, and Niba Hiweinen, and other cities in the north. If you consider how the Anhui provincial government's network is all linked up, how it's all connected. Get it? Remember that case I mentioned? I accidentally rebooted the device, and the phones went crazy, with calls coming in from all over, because everything controlled centrally here. This is what I mean. Centralized management and control. Take the government network. If you visit the government affairs office, you'll see a diagram in the network office that shows how Anhui province's government network is connected. Here at Tianjin Lake in Hebei with a hub reaching out to surrounding areas. So it handles a wide range of services. That's what government agencies and businesses need most, because they need to meet business needs. Take our government affairs network, for instance. On the other side, you have the Department of Finance, right, and the various other agencies, like the Environmental Protection Agency, the Health Department, and even the Civil Affairs Bureau. These are all government agencies. Their networks are all under centralized control. Got it? So all these different agencies are grouped together. This is a typical example of a government network. They have a wide variety of business types. That would also include transportation and public security, right? So their network equipment has highly complex functions. They demand very high security and flexibility. So you often need to fulfill customized needs. One solution can't satisfy every client. And now let's look at large data centers. Are generally called IDCs or data centers. This was actually covered in Huawei's earlier certification program, essentially. So what's a data center? You know those server rooms you see around. Exactly, server rooms. So what's inside the data center? Inside, you'll see rows of server racks. And inside those racks, there's more than just network equipment. You'll mostly find servers and storage devices. So a data center houses all of this. Take, for instance, our current needs, the needs of organizations, and these needs are energy efficiency, vast storage rentals. A data center, for example, might host your company's website. Your company's services are hosted in these data centers within a server facility. Not on your company's internal network, you see. So companies often rent data center space. For instance, renting is becoming more common. Providers like Alibaba Cloud and Tencent Cloud. Actually, they all have their own data centers. This involves network automation management. It involves virtual machine deployment. Nowadays, data centers are mostly virtualized. That's why virtualized deployment involves automation management. What I mean is, when we use cloud computing, we need to rent a server. Simply put, like with Alibaba Cloud, it's especially useful for businesses, especially for startups launching new businesses. Say you go out and buy some hardware. the resources you spend, the cost involved. It's better to just rent from Alibaba Cloud. Take Alibaba Cloud's flagship product, their cloud servers. For example, if you want to rent a server, Alibaba Cloud servers, just look, it's 416 yuan a month. It's just a drop in the bucket for the company. So what kind of performance do we get? Look, it shows us the frequency of the core processor. The maximum internal network bandwidth is 10 gig. Solid drive, right? And look, 16 gigabytes of RAM, 8-core CPU. So how much does it cost? You can even customize it, like choosing your own specs. What memory are we looking for? What hard drive? You see, if we're here, we choose right now. I want to change this to one of these. Get one like this. Just log in with Taobao. This is the backend, the data center management. Take a look. We've never done this before. We've dabbled in cloud computing, you know. Alright, everyone. Okay, I'm going to buy one. I can buy the pre-configured recommendations, or I can customize my own. See, I'll pick my own specs. Yeah, I'll choose everything myself. I'll get a device in the North China region. And then, how many CPUs do I want? I want a quad-core. How about memory? I want 16 gigabytes, okay? And then, what OS should I install? They're listed below. Take a look. What OS do I want? Right, all kinds of OSs. The familiar Windows, and then even many computers. Even mainframes, you know, it's Linux. For CentOS, I'm gonna install CentOS 7.4 64-bit. Then for the disk, I want an SSD card disk. I'll go with 500 gigabytes. Okay, alright, here's the price. 8,017. See, just 8,000 a year. Just 8,000 a year. That's not expensive for a business, is it? What do you mean? I can choose all these myself. Have you thought about this? After I've chosen and purchased it, the device is generated. What's the deal with the buying equipment the traditional way? Think about it. This is automated virtual machine management and deployment, smart deployment. Just select your desired performance, and the backend instantly generates a corresponding virtual machine. This is what I mean by cloud computing. This is the foundation of cloud computing. Without virtualization, there's nothing to it. Cloud computing is hard to achieve without it. So this is Alibaba Cloud. It's based on virtualization. So you think you can just pick and order right away? Someone's already buying this. Hurry up and buy servers off the market. A quad-core with a memory. Perfect for this hypersystem. Do you think that's possible? This is what we mean. This is the current demand for data centers. A general overview. So this shows you just how many connections we'll have. Let's look at a real network. This network is quite complex. You typically see this in large enterprises. We have servers here. We have devices for the access, aggregation, core, and egress layers. Take a look at this. This large data center uses Beijing technology. We use this technology to achieve physical server migration. Why is this called a data cloud network? Just look at the bandwidth they're using. It's actually 40G. Can you believe it? Most of our desktops are using 100 megabits per second, or at best 1 Gbps. This kind is 10G, the backbone is 40G, even 100G, they're all using BGP. Right, let's check out some other industries. Hotels. First, let's get acquainted with this network architecture. What's special about hotels? Take this diagram, for example. We see some VPN here, right? Hotel headquarters. For example, let's say Hanting. Right, there are various branch locations. For instance, the guest room network, office network, and say over here, we have the guest room network, office network. Moving on, say you book a room at any of the locations nationwide. You can check room availability. In the case of hotels, you'll see they connect to the VPN via headquarters. Once connected to the VPN, our data is sensed and shared. It's all managed centrally by headquarters. Headquarters can access all branch information. So, as you can see, for the guest room network or the office network, besides the usual laptops and desktops, surveillance is a must. There's also wireless equipment, so we have wireless APs. The switch connects to the outbound router. The router might also have an AC. AC is used because, it's a hotel. There might be several buildings, so there are many APs. They're centrally controlled by the AC. ACs are used to centrally manage APs. This is for wireless networks. and firewalls as well to control our bandwidth and traffic flow. Now let's look at K-12 school networks. Let's take a look at the diagram. What are the characteristics of K-12 and university networks? They have many different locations. Right. You need network coverage in classrooms, offices, libraries, and dormitories. Primary and secondary schools might not have much network coverage in dorms. Universities, however, often connect to branch campuses. And schools, they often have their own special network called the education network. China has 5 major networks. Besides the 3 you know about, Telecom Mobile and Unicom, there are 2 others that you might never come across. One is the education network, and the other is the research network. These 2 networks are not as widely used. We usually use broadband from China Telecom, or from China Unicom or China Mobile. You got that. But these are specialized networks, such as the education network and the scientific research network. Those are 2 other networks. So we use the internet normally, but educational institutions might need to use the education network, which has its own resources when accessing certain sites. It's not the same as accessing the regular internet. These APs or access points are similar to what we discussed earlier, handling connections for our wireless devices. Now let's take a look at universities. Right, universities. I have attended Jiao's lectures from what you often use network services from some universities as examples. Take Peking University and Beijing Jiaotong University for instance. Beijing Jiaotong University Student Organization. You've all been to college, right? We usually just hang out in our dorm rooms, just plug in an Ethernet cable and we're online. But have you ever wondered, how does our data get transmitted? Through what kind of equipment? To what areas? And using what technology to reach the internet? And then the data comes back to us. Right, this is what we did. Let's take Anhui as an example. Anhui's largest, Anhui University. I have a diagram of Anhui University here. Let's look at the characteristics of Anhui University's campus network. Different buildings and areas, like the administrative building, library, lab building, right? Dormitories, right? Faculty dorms, correct. Ultimately, these networks are all integrated. So this is the campus network. It has many different operational needs. This is actually similar to our government agencies. Moving on, as for small and medium-sized businesses, their setup can be simpler. Basically, it's just to get employees online. We might have a solution like this. We can use a single device, a broadband router, right, which acts as both a switch and a router. It's also a wireless AP. Or we might buy separate, dedicated devices, like wire switches devices, wireless access points or switches, and also gateway routers. Different solutions fit groups of, say, 10 to 50, right? Or even 10 to 100, even up to 1,000, right? District and county-level governments, like the agencies we mentioned, you need to look at the bigger picture. Say, we're the Hefei city government, and under us are districts and counties across wide area networks, and some branch offices. See what I mean? These are all different cities. They actually rely on the operator's MPLS-TP. It's mainly about MPLS-TP. You'll also need BGP for this. So to master the network architecture of a government network like this, an NA just won't cut it. You need to study up to the IE level, an I-level engineer. Check out what they're saying. There's something they often mention. Once you get to IE level, you really start to grasp what MPLS-TP really is. Because this technology requires a foundation in BGP, you need to master the basics of MPLS-TP, and then build on that for MPLS-TP. My previous student did his graduation project on MPLS-TP. This student here, I have his graduation project here. You can take a look. This is it. It's his graduation project. Take a look, you'll see. What's his project about? This project is top-notch. He graduated in 50, PRTPP done by his service provider. So he did a project like this. See that? I planned out our project. It involves the CCB Shanghai branch and the Hefei branch, China's telecom backbone network, a branch of Ping An Bank and Insurance in Hangzhou, Beijing HQ of China Construction Bank and Ping An Bank. He's capable of planning or understanding such a network. A look at the title. See that? Right. It involves these organizations, so this is no ordinary task. It's beyond the scope of junior engineers. Our junior engineers might only be familiar with a single branch or Shichu. They'll be working across the carrier's network, this network, integrating all the HQ and branch networks. That's what his thesis covers. So, as you can see, they're using top-offline equipment. Since he's working for a carrier, he's familiar with this equipment. He's worked with them before, so this thesis is a perfect fit for him. We'll skip the rest. So this is what we mean by indirect involvement with the government. So what's special about the networks? Alright then, I've already optimized this part. This first chapter is mainly to give you an overview of the course and the tasks that follow. But more importantly, you need to know what you can do with it once you've mastered it. You got that. It impacts every aspect of your work and even your life. That's where network companies come in. They're essential for building this infrastructure. So it's not just your average company. It even includes large corporations and government agencies. So the things we deal with, there's a lot to learn. It's a comprehensive course. Alright, so we need to cover this. First, you need to have a basic understanding. Don't focus on that for now. Don't worry about passing the exam, because passing isn't guaranteed. We have very comprehensive review materials. Basically, you get it, right? But here's the thing. Having a certificate doesn't guarantee you have the skills. At the end of the day, companies want to see practical skills. It's the same in interviews and on the job. It all comes down to your technical skills.